many things in Azure Data Factory, but I like to simplify it in two main tasks. You can copy data using Data Factory, and you can transform data using Data Factory. Now, copying data is the core task of Azure Data Factory. You can copy data from more than 80 connectors or in between 80 different applications in Azure. These applications may be software as a service kind of applications like Dynamics 365 or Salesforce, or these applications may be on-premises data stores like SQL Server or Oracle, or these applications may be cloud data stores like Azure SQL Database or maybe Amazon S3. So basically you can copy data from application in any environment to different application in any other environment. And not only that, while copying, you can also convert file formats. You can also zip file. You can also unzip file. And you can also map the columns between the source and the destination. So for copy data, Azure Factory is very widely used service within Azure. Now, in addition of copying data, you can also transform the data. And previously, the only way to do this was using the external services like Azure HD Inside or Databricks or maybe SQL Server Store Procedures. You used to use these services and integrate the notebooks or the code of these services with Azure Data Factory. But very recently in 2019, Azure Data Factory added the data flow task. Now this data flow task is very much like a data flow in the SSIS, and it has all possible kind of transformations. Now you can both copy as well as transform the data right from the same interface in Data Factory. And this makes Data Factory a complete ETL tool or data ingestion tool. Now, those who wants to read the official definition of Data Factory, for them, Azure Data Factory is a hybrid data integration service that enables you to quickly and efficiently create automated data pipelines without having to write any code. Now, in this module, we will learn about the Azure Data Factory, a hybrid data integration service that simplifies ETL at scale. It enables modern data integration in the cloud by providing visual tools to integrate data sources. As I said, we have more than 80 connectors, and these 80 connectors allow you to move, transform, and save data between very diverse data sources. Also, Azure Data Factory is a fully managed cloud-based data integration platform that helps you to create data-driven workflows. And we use these workflows to orchestrate and automate data movement and to transform and store the data we search. And Azure Data Factory can also help you operationalize the process needed to move and transform this data using ETL or ELT kind of scenarios. Now, if all this sounds very confusing to you, I would recommend you to go back to the previous definition, the simple one, where we understand Data Factory as a tool to copy and transform data. You just see Data Factory like an SSIS. It's a cloud version of SSIS. Thank you. When we read about Azure Data Factory and we read about the wide variety of functionality supported by Data Factory, we tempted to use Data Factory everywhere for every task. But that is not the case. Azure has more than 200 services, and many of these services designed to do particular specialized tasks. So for example, let's say if you want to do the migration, then there are specialized services like Data Migration Assistant or DMA, or there's a service like Database Migration Service or DMS. These services are designed to do migration. They are optimized to do migration. So we want to use those services for migration, even though we can use Data Factory for migration. But since Microsoft has provided those specialized services, it is preferred to use those services. However, if we want to have some kind of requirement where we want to periodically migrate our data, then we should consider using the Data Factory. Similarly, in case of streaming, we have dedicated service to handle data in streaming. For example, we have IoT Hub, we have Event Hubs, we have Streaming Analytics Service itself, which is especially designed to handle streaming data. However, we can still use Data Factory for orchestration purpose. We can use IoT Hub or Event Hub or streaming service within the Data Factory, but Data Factory in itself is not designed or not optimized to design to work for data streaming kind of scenarios. Similarly, when we talk about the transformations, Data Factory have now data flow task, which is specially designed for transformations. It has many transformations and it is so easy to use. It is just a drag and drop. You don't have to code anything. But still, if you require complex kind of transformations, Databricks or HD Inside are still preferred to design your complex logic within and then orchestrate that logic from Data Factory. For example, we can design the notebook of Databricks and we can run that notebook from within the Data Factory. So most of us who are coming from on-premises environment, we have been using SSIS now for decades. I think SSIS and before that DTS, they are in the market from last 2 decades now. And SSIS is now almost can fulfill all of your on-premises need. It's a very mature service, very easy to use, code free. This is just drag and drop and you can achieve your task, just fill some of the configuration and that's it. So it can almost take care of all of your on-premises requirement. And SSIS is now also have Azure plugin, and through that you can also access Azure resources. But again, the point is, it is not designed for that. SSIS is not designed to work in the cloud, even though you can do some of your data related tasks, but that is not designed to work in the Azure cloud environment. Now, on the other hand, Data Factory is still in developing stage. Microsoft is adding so many transformations and different functionality within Data Factory every month, I would say. Recently, data flow have been added a couple of months back, which enhanced the functionality of Data Factory in terms of transformations. So Data Factory is still developing. SSIS is very mature from on-premises point of view, and SSIS is more of a code-free transformation. Data Factory advantage is that it is very scalable. You can quickly add more and more processing power in Data Factory very quickly. And as far as SSIS is concerned, SSIS has many connectors, which is more helpful in on-premises environment. For example, SSIS has Excel connector and similarly other on-premises connector. But when we talk about Data Factory connectors are more focused on cloud related services. Now Data Factory has, I think, more than 100 connectors, and it can connect with almost any cloud related services, not within Azure, but also with AWS or Google or other cloud-based services. Also, Data Factory has many unique functionalities. For example, it has the event-based trigger. You can create a trigger based on a particular event. For example, you can say if the file is being added on particular data lake or blob storage folder or container, then the event will be triggered, and that trigger will start the data factory pipeline. And another good thing about is that if you have been working on SSIS for many years, you must have or may have hundreds of SSIS packages. Now you don't need to rework on those packages. You can run all of your existing packages from within the data factory. So I hope this is big relief for all of us. So once again, the point is, if our work is more focused on on-premises environment, we should still choose the SSIS. But if our work is more in the cloud environment, then we should choose the data factory. All right, so now let's discuss some of other important considerations for Azure Data Factory. Azure Data Factory has two versions, version 1 and version 2. Version 1 is older version, which is basically based on JSON code, and version 2 is having a graphical interface, which is ultimately on the background convert to JSON, but you don't have to do it. So it is very easy, simple drag and drop based portal. So all your new projects should be based on version 2. In fact, Microsoft recommend that you should consider converting your existing version 1 also into version 2. And then you have many different options to interact with the Azure Data Factory. You not only have graphical interface, but you can also use PowerShell. You can use .NET, Python, REST, or Azure Resource Manager or ARM template to interact with the Azure Data Factory. And Azure Data Factory is designed to have seamless integration with all other Azure services. For example, Azure Data Factory can easily interact with DevOps to manage your code. It can interact with the Key Vault to securely save your credentials, or Azure Monitor to have a monitoring needs, and then automation to automate start and run, and also with other services like Databricks or HD Inside for your machine learning related projects, and with other services also. So the point is, Azure Data Factory easily, very seamlessly integrate with other services of Azure. And then we have no data storage. So Data Factory is a service which transform or process data. So it read the data, process data, and then save data. But Data Factory in itself does not store the data. Data Factory is not a storage service. So after processing, we have to store or finally save that data in some kind of storage services. And finally, security standards. Microsoft is very serious about the security. Security is always the first preference of Microsoft, especially in Azure related products. And it uses HTTP or TLS when your data traffic move from one service to another service within Azure, and it is always encrypted. It is very secure. So in this lesson, we discussed that even though Data Factory provides so many capabilities, but we should not start using it blindly for all the purposes. Microsoft have different services specially designed for particular task, and we should use those services. And then we discussed the difference between the SSIS and Azure Data Factory, and in which scenario which service should be used. And finally, we discussed some of these considerations for Data Factory which we should keep in mind while working on Data Factory. I hope this is helpful to understand a little bit more about Data Factory. Thank you. Hello friends, welcome back. And in this lesson, we are going to create a brand new Azure Data Factory. So if you go to all services here, and within database, you should be able to find Data Factory. Or you can also go to analytics and you can find Data Factory here also. And you can also look into another category like integration, and you can find Data Factory here. And maybe it is there in some other categories also. Or you can always search factory here and you can see Data Factory right here. And let me add a new instance of Azure Data Factory. So the first thing is we need to provide a unique name to Azure Data Factory. And if I type ADF, I'm pretty sure I'm not going to get it. This is pretty common. So let me add some unique number here to make this name a unique. And in your production environment, you want to follow the naming convention of your company to name this data factory. And then we have version 1 and version 2. Now for all practical purpose, we use the version 2. Version 1 is very old. It was released in August 2015. And at that time, Data Factory used to be a very simple tool. There was not much here. In fact, there was no interface at that time. You used to do, you used to develop the solution using the Visual Studio and, edit JSON manually. So it was pretty old one. And then Microsoft released new version of Factory in September 2017. And there were so many capabilities in this new version. And that was the reason actually Data Factory released it as a new version, because there were so many different capabilities was there. For example, from version 2, you had the option to lift and shift your existing SSIS packages into Azure, or you had an option to schedule your pipeline, or you can do the looping or branching and so many different things. It was almost a new product, and that's why Microsoft or Azure released this as a version 2. So now for all purpose, whenever we talk about Data Factory, it means version 2. And here, as always, we need to select our subscription. And as you know that subscription is for the billing purpose. I only have one subscription, so I will choose it. And here we need to choose the resource group. And as you know, we use the resource group to organize all our resources into different category to make sure that we can manage them well. So I will use this resource group RG course demo here. And then we have the location. Location is important because we want to create all our resources at the same location if possible, or close to our users. So for demo purpose, I'm fine with the West US 2. It is close to my existing location anyway. So right now I'm not using Git, and we'll talk about Git sometime later, but this is enough information to create our brand new Data Factory account. So let me click on create, and I think it will take few seconds to create this new account. So let me pause my video here, and I will come back when it's complete. All right, it completed. So we can go to deployment details here, and we can look at the operation details, and you can see here it just took 6 seconds to create Data Factory account. Actually, when I stopped my recording, on very next second it was completed, so I started it back. But anyway, we can go to the resource. Let's click on go to resource, and now we are inside the Data Factory. And as this is the brand new account, you can see most of our monitoring chart are blank here. And on the left hand side, you have these common options like activity log and access control. But still, there are pretty less options than compared to other services. And of course, we have monitoring options here, which we will look into different module. So let's go into author and monitor to start a Data Factory in the separate browser. So let me click here. And you can note here, it is opening as a adf.azure.com in the separate browser. All right, so now I'm inside the home page, and here you can see you have a few shortcuts. You can create a pipeline, or you can start a copy data wizard from here. Similarly, you can create a data flow, and you have few other shortcuts here. If you go a little bit below, you have few videos here. These are good videos if you want to see what are the new enhancement or announcement from Data Factory, and you can find all those related stuff here. And below you have some tutorials. I would recommend you can go through these tutorials. They are very good. I would suggest you to take a look at these videos also. So this is our first page and home page, you can see here. And if I expand this here, earlier it used to called home, but now it says the data factory. And the next page we have is the author page. And this is the main development area. This is where you are going to spend most of your time. You create your pipelines and data sets and all kind of mappings and everything in this page. And we will go into all that detail later, but I just want to let you know that author page is the development page. And then you have the monitor page. And as the name suggests, this page is used to monitor your existing ongoing jobs, or in fact to look at the history. It keeps track of history of all your pipeline runs. And you can see here, you can monitor your triggers and integrated runtimes, and you can set an alert, and you can look at the metrics from here, or you have the dashboard here. So we will go through this in detail in upcoming lessons. And then in the last you have manage, and this is pretty new here. And from manage, you can look at the existing linked services and integration runtime, source controls and triggers, and few other things. And these things we used to access from different pages earlier. For example, if I say the link service, if I go to author, and this is the connection for link service, but if I click here, it says the connections are now located in Azure Data Factory's new management hub. So if I click on open management hub, it comes to the manage page. So earlier we used to have these 3 pages. Now we have manage also, which is good. So this was the quick introduction to the user interface of Azure Data Factory. In the upcoming lessons, we will understand all these components in detail, and we'll go through some of these shortcuts, and we'll try to understand this interface and functionality of Azure Data Factory. Thank you. Hello friends, this lesson is going to be very important. In this lesson, we are going to understand all the important components of Azure Data Factory. And it is very important to understand these components in order to have a good understanding of Azure Data Factory. And I'm going to start this lesson with an example. So for example, let me start my marker here. And so for example, let's say we have one cabinet which is in the shop, and we want to transfer this at home. Now we need some person who can help us do that. So we'll try to find that person. And let's say I found that person, delivery man, who is going to help me to shift this cabinet from shop to my home. Now, when I was discussing this delivery man, now the first thing this delivery man asked me is about the detail, and I provide him delivery details. Then the next thing he asked, how I'm going to disassemble this cabinet at shop, and later how I will assemble it back at the home. So I had to provide him both of these details, how to disassemble and how to assemble. And then final question he asked me that please give me the address of both the shop and the house, and also give me the some way that how I'm going to enter into the shop and how I'm going to enter into the house. I said, yes, I'm going to give you that detail. So I provided him address of both shop and house, as well as I gave him the keys through which he can enter the shop and the keys through which he can enter the house. Now he has all required information. So he has address to reach to the shop. He has keys to get into the shop. He can pick the cabinet, disassemble it. Now he has all other required details. Finally, he can reach to the house with this address, and then he has the keys to enter the house. And finally, he also have assembly information to assemble the cabinet back at the house. Now, I may have many such projects, so I need someone who can oversee all of these delivery men. So basically I need a delivery manager who can work with many of these delivery men and can get all these small tasks done. Now this is very easy example, but if you understand it well, we can exactly replicate this example with the Azure Data Factory components. Alright, so now let's see that how this example fit in our Azure Data Factory environment. So if you look here, we have integration runtime. This is the one who handle the entire job. It is called integration runtime. So basically integration runtime provide an infrastructure to run any activity. Now activity can be any task. For example, here we have the copy activity. We can have wait activity, or maybe any other transformation, any other task is called activity. And then we have data set. Data set is like assembly or disassembly information. It is like the structure of data. What kind of data we are dealing with? Is it text file or some kind of table? Or if the text file, how is the data look like? Is it comma separated table? Does the first row have the column names and all that? So basically to understand data we are dealing with, we call it as a data set. And then we have linked service. Linked service in simple terms is a connection string. How to connect with the source, how to connect with the destination. It has the credentials. It has the address like server name or the service name where we are trying to connect. So linked service is basically a combination of address and the credentials. And of course then we have the source and the destination. Source can be Blob storage or any other service. And then we have the finally data which we are trying to move from one location to another location. And of course in destination we can have different services. And this all is kind of one big task. And then we have Azure Data Factory pipeline at the top, and this pipeline can have many of such tasks. So in one task, maybe we are copying data from source to destination. Then data pipeline may have another task which actually transforming this data, and then maybe another task which is maybe saving this data on the destination. So data factory is like a delivery manager, and many of these such kind of delivery men work under such a pipeline delivery manager. So if you're coming from SSIS background, I want to compare these services with SSIS so that you can easily resemble it. So I have this comparison here, and if you see in SSIS we have a packages, but in Data Factory we have pipeline, and which is very similar to packages. Then in SSIS we have the connection manager, and in Data Factory we have the linked service. So you see we have linked service here. Now this linked service is, you can just think of it as a rename of connection manager, but it is almost same as connection manager. It has the address and the credentials and all, which is used to be in the connection manager. So it's almost same. And then we have source in SSIS and Data Factory, which is same. And then we have destination in SSIS. In Azure Data Factory, we called it as a sink, but it is same thing. It's just a rename of destination. And then we have control flow task. And in Data Factory, we have activity. For example, copy data is one of the activity. And it is like a control flow activity, I can say. As we have data flow in SSIS, similarly we have data flow in Data Factory. So I'm not showing it here, but you can assume instead of copy activity, we can have data flow activity here. And within this activity, we can have many transformation, tasks inside that data flow, similarly the way we have in SSIS. And we are going to discuss that in detail in upcoming lessons. Now, in the upcoming lessons, we are going to discuss each of these components in detail, and then we are going to have some demo where we will be using these components to perform some tasks. Thank you. Hello friends, welcome back, and in this lesson we are going to discuss a little bit more about pipeline and activities. Right now I am inside my Data Factory portal, which we created earlier. And on the left hand side, I have the author plane. And if I go inside this, let me collapse this. So this is the area where you are going to spend most of your time developing Data Factory. And on the left hand side, you can see we have options to create a new pipeline or new data set, data flow. We have connections, triggers, and other options, which we are going to see in next few minutes. So let's discuss first about the pipeline. So in pipeline, we have option here to create a new pipeline. And as soon as we create a pipeline, you can see that we have options here to create activities within this pipeline. And on the right, we have option to change the name and provide description and other details about this pipeline. So let me close this. And this is the area where you will be creating a pipeline, and you can create more than one pipeline at a time. And not only that, you can actually create a folder here. And within this folder, so for example, I can say project 1, and my pipelines related to this project I can create within this folder. And similarly, I can create a multiple folder here, folder inside folder, just for example, project 1, team 1, something like, or maybe you can say test or prod or stage or something like that. Or you can create one more folder here. So basically the point is you can create a folder structure here and organize your pipelines within these structure according to your business need. So let me delete all these folders to avoid confusion. So right now we have this one pipeline. All right. So once we create this pipeline, as I said, we have now options to create the activities, and all these activities are divided into the categories, and you can see all these different categories here. And if you want to see all of these activity once, you can just click here and you can see all these activities. So for example, I can take one activity and just drag and drop here, and you can see that it's so easy. And as soon as I select this activity, copy data activity, I can see all these options below which are related to this activity. So because this is copy data activity, so we have source or destination or mapping and other settings and other related options for this activity. If I choose some other activity, for example, let's say if I choose wait activity here, then I have options here related to wait activity, and these options will change as I choose different activities. And every activity have the property which we, for example, this copy data have the properties like success, failure, or completion. So for example, if this activity succeed, I want to execute this activity. Or if this fails, for example, let me put some more activities here. So let's say if I put notepad here, notebook here. So if this fails, then I want to execute my notebook of Databricks. Similarly, I have if this complete, whether it's a success or fail, or if I want to skip this. So basically, we have different properties of every activity. And based on the result of this activity, I can design, the flow, how my next activity should run. And this is very similar to SSIS if you're coming from that background. And then you have option to delete this activity if you don't need it. Or let's say if you design this activity, you fill all these options here and you want to have similar activity, you can just clone it. You can just copy it, and this will create one more activity with the same options here. So let me delete this right now. And then you have option to see the code of this activity. So for example, if I click here, I can see the JSON code behind this activity. So if you remember, we discussed that behind the scene, this interface create a JSON code. In Data Factory version 1, we used to have only JSON code, and we used to edit that JSON code. But in version 2 we have this wonderful interface where we can just so easily drag and drop these different activities and fill out these configurations and all. But behind the scene, all this code ultimately convert into JSON. So for this activity, if you want to see the code, you can click here. If you want to see the code for all the activities or for this pipeline, you can go ahead and click here, and you can see all the activities here. Now, once you design your pipeline and it looks good to you, you can validate it. And once you click here, it will check all the properties and if you have provided all required information. And if there's some error and if you missed out something, it will let you know. For example, let me click on validate. Since I have not put any of this configuration, it is mentioned that source type is required, since type is required, because I have not put anything here. But I'm just trying to tell you how to use this validate function. And once you validate it, you can save it as a template if required. If this is something you want to use again and again into different pipelines, you can save it as a template. In fact, when you create a new pipeline, you have option here to create a pipeline from a template. And if I click here, you can see all these ready-made templates created by Microsoft. And you can try to find if there is any template which can fulfill your need. You can just directly grab it instead of creating it from scratch. Or as I said, you can design new pipeline if required, and you can just save it as a template which you can use later. Now, since we're talking about activities, we saw that activities are divided into different categories according to different services. For example, all Databricks related activities we have here. We can create a notebook of Databricks, and we can run that notebook from within this data factory right from here. Similarly, we can have a USQL query of data lake which we can run from here, or we can have HD inside related queries like Hive query, Pig query, or Spark query, and we can run those queries right from within the data factory from here. Now, again, these activities are also divided into another kind of categories. In general, at the very high level, we divide the activities into three types. One is the data movement activity, which is used to move data from one source to the destination, and generally we use a copy data for that. And then we have data transformation activities, which we use to process the data, which we use to convert the data or clean the data or transform the data. And for that we can use many activities. For example, within Databricks we can use Notepad. We can write Python code or SQL code or different languages supported by Notebook, and we can create a notebook, and we can use that notebook right here to process our data. Or similarly, we can use HD Insight, all these different kinds of activities. And then we have control activities. Control activity means which control the flow of our pipeline. For example, if I go here, iteration conditions, we can see for each loop here, if condition, switch. And once again, if you're coming from SSIS background, these are very similar to the SSIS. So we have all these control loops or conditions which we can use to have a proper flow of data or decide our overall pipeline flow. So these are all the activities. And then once you are satisfied with your pipeline, and if everything looks good, you validate it, everything's fine, you can go here and publish this pipeline. Publish means you are saving it. You are putting this pipeline on live, and you can run this pipeline. And you can run using Trigger, which we are going to discuss in upcoming lessons. And before I finish, I forgot to mention one very important activity, and that is data flow activity. And you can see we have a separate section of this one particular activity here. So data flow has all the different activities inside to transform your data. So for example, if I create this activity, it is asking if I already have this activity, and if I say no, I want to create a new activity, it is asking whether you want to create a mapping data flow or a wrangling data flow. And you can see wrangling is still in the preview. So mapping data flow means if you want to transform data right from within this portal, this interface, without writing even a single code. And wrangling means to prepare your data using Power BI queries. We are going to have a separate dedicated lesson to discuss about data flow and a demo to understand this. So for now, in this lesson, my purpose was to make sure you understand what is pipeline. It is a logical grouping of activities, how we drag and drop activities, how we connect it, how we configure the properties of each activity, and then we validate it. If required, we can save it as a template, and then if everything looks good, we can publish it. So let me quickly go to the slides to make sure we have notes of this lesson. All right, so we are talking about data pipeline here. So data factory can have one or more pipeline, and we see that how we can create even the folders and organize all of our pipelines. It is a logical group of activities. It manage activities as a set. We discussed that, how we can create different activities, connect activities with each other. And then one pipeline can have one or more activities. And then it represents a processing step in the pipeline. So activities represent processing step in the pipeline. It is kind of task which process the data. And we can have different actions like ingest, transform, or store the data. And these activities can be linked sequentially or even parallelly, as we discussed that using success, failure, or completion task. And last but not least, we have three types of activities. We have data movement activities, which move data from source to the destination. And there are many connectors. There are, I think, more than 90 connectors now to connect with a different source and different destinations. And we have data transformation activities. As we discussed, we can use Hive, Pig, Notepad, and different activities to transform our data. Or we have full-fledged data flow activity to transform our data. And then finally, we have control activities to control the flow of our pipeline, maybe for each or web or if and all different kind of activities. And then finally, we talk about the data flow. So data flow is a new feature. It's very new, in fact. And that allows you to develop graphical data transformation logic that can be executed as an activity within Azure Data Factory pipeline. So graphically, we will define a transformation logic which can be executed as an activity. And there are two types of data flow. One is the mapping and one is the wrangling. Wrangling is for data preparation and mapping is for data transformation. Thank you. In last lesson, we discussed about the pipeline and activity. And we saw that pipeline is a logical group of activities. We can create one or many activities within the pipeline. Now, to define activity, for example, the copy data activity, we may need linked service and dataset. And if you remember, we discussed that linked service contains two things. One is the connection or address to the store and the credential or key to enter into the store. And dataset is a reference point of actual data in the store. So this represents the schema or the structure of data at the store. So when we are working with copy activity, we are only concerned about the dataset. But behind the scene, the same dataset is actually pointing to the data at the blob storage. So actually, if you see, linked service and dataset, they both go hands in hand. So to define dataset, we also need to have linked service. So let's go into the portal and see how all this work in the UI. Alright, so right now I am inside my portal and this is where we left the last time. And on the left hand side, you see we can define we can create the new data set here. But if you choose any activity, for example, the copy data activity, you see all these options below. If you go to the source, you also have option to choose your data set here. And if you do not have any, you can also create new data set right from here. Similarly, in the sync, you also have this option. Now, there may be some activities which may not require to have data set. For example, the wait activity. Wait does not have any requirement to create or to store data set. So we do not have a data set in the wait activity. But anyway, the point is you can create a data set right from within here, or you can create from here. Now, when we create a data set, we also need to create a linked service. For example, let's choose some storage here, source storage, and I will explain this in a minute. But right now, let me choose something. For example, let me choose blob storage and click on continue. And what kind of data I'm trying to connect? So let me choose a text file. So here is the option where we can choose the existing linked service. And if we do not have any, we can create new right from here. So let me cancel this and let me first create a linked service, and then we will connect that linked service with the data set. To create a linked service, we can go into the manage tab. So we have this manage tab here, and here we have option for the linked service, and we can create a new linked service. Now, all these are different connectors to connect with different types of sources. And right now, at the time of recording, I think Azure has more than 90 connectors. Actually, they're increasing every day almost. So earlier they had 75, then it became 80. Now I think there are more than 90. And there are different categories here. So for example, Azure related services. So we have a blob storage, data lake Gen 1, Gen 2, file storage, SQL Server, and all these different storage services within Azure. And then we have outside Azure. We have DB2, Google BigQuery, Hive, Oracle Database, and all that. Similarly, we have file type of storages, generic protocol, NoSQL, MongoDB and all, and different services to connect with. So we have Dynamic 365, we have Dynamic CRM, Office 365, Oracle service. So all these are different services and application connectors, and we can connect with any of these services using these connectors. And all these are under the category of data store. Similarly, we also have option for compute, and this is to connect with compute related services. So for example, we have data lake analytics, we have Azure Databricks. So these are services, compute services, and we have these connectors to connect with these compute services. So we can search here if we are looking for something. So let's select for blob storage and click on continue. So here we need to provide the name of linked service. So I can say, let's say ls blob. And in this demo, I'm trying to connect with my another storage account. The name of storage account is Azure Storage. And this is the container ADF input 01. And in this container, we have this one file, input employee. And if I open this file, you can see we have a very simple file, just first name, last name, and 2 values. I just want to show you an example. So we are trying to connect with the Azure Storage account. So let me give name here Azure Storage. And then if you want, you can give some description of your linked service here. And then we need to connect with the integration runtime. And by default, we have auto resolve integration runtime. And in this case, Azure figure out what is the best configuration for you to connect with this link service. You don't have to do anything. This is the default one. And in the upcoming lesson, we are going to discuss all different kinds of integration runtime. But as of now, let's just choose the default one. And then we have different authentication method, how we are going to authenticate to enter into the storage. And once again, we have different options, and it is kind of out of scope, of this lesson to describe all of these. But default is account key, which is good enough. Right now, let's just choose the account key, and maybe in some time in security section, we'll discuss all these different kinds of authentication method. And then you have again 2 options. Where is your connection string is stored? You can directly choose connection string, which is also default, or you can choose the Azure Key Vault if your connection string or your credentials are stored in Azure Key Vault. So as of now, let's just choose the default one, which is connection string. And then, you have this connection string information. You can take it directly from Azure subscription, or you can manually enter it. You can manually enter the storage name or account key and other information. But let's just choose the Azure subscription, and we can choose our subscription here and which storage account we are trying to connect. So if you remember, I'm trying to connect Azure storage. This is my Blob storage account, and I just select the storage account right here. And that's it. You don't have to do anything else. If you want, you can also give the file path here, for example, the container name and directory name here. But I don't want to give it right here. We can give it later also when we define the data set. So I'll give it that time. So, and that's it. You don't have to give anything else, and you can test your connection. It is successful, and you can just click on create here, and this will create a new linked service to this Blob storage account. Now you can use this linked service when you create a data set. Now this is you have as a connection and a credential to get into the storage account. So now let's go back to our author tab here. We are in the author tab once again, and here we can create a new data set. So let's create a new data set. And if you remember, we are trying to create a Blob storage. So let's choose once again, and then what kind of file we have. If you remember, we have the text file, so I can choose text. Otherwise we have option for JSON, Excel, binary, and ORC and other options. So let's choose text as of now and click on continue. Now here we need to give the name of our data set. So we can say data set for Blob text file. And then here we need to choose the LinkedIn service. And again, we have option here to create a new linked service, but we already created one. So I will just choose it, right from here. And here we need to define the file path. So once again, I will choose my folder, which is ADF input 01, and this is the file input employee.txt, which I'm looking for. So I will choose this file from here. Do we have first row as a header? So let's look at the file, and we have first row as a first name and last name. That means first row is like a header. So let me just choose here first row as a header. And from where we want to import the schema, from our connection, connection to this file, or maybe if the data is very complex and it's not very obvious that what kind of schema it has, then we also have option to define a separate file. We can upload it, and this file will define the schema of the file, of the source file. But in our case, we have very simple file, and we can just directly choose schema from the connection, and I will click on OK, and that's it. This has created our new data set. And here we have the properties to, once again, if you want, you can change the name, and you can give the description of data set here. And now here you can also go into the schema and see the schema. But if you see, this is not right. This is taking our column name as a one column name, which is first name and last name, which is not right. So let's see what's going on here. So if I click on connection, I can see the column delimiter is like comma here, but in our file it is not comma, it is pipe kind of separation. So let me go here, and from comma delimiter I can choose pipe here, and once again I can go back to the schema, and I can click on import schema from connection, and now we have two separate column name, first name and last name, which is pretty good. And then we can also define the parameter here for the data set. We are going to discuss parameter in separate lesson. But right now, within connection, we can see all the configurations of the data set. We can, if required, we can change the LinkedIn linked service here, or we can test the connection here. We can create the new linked service. We have the file path here. Where right now it is pointing to input employee.txt file. We have compression type, column delimiter, and other information regarding file right here. So if required, we can change all that configuration into the data set. Now let's go back to the pipeline, and once again let me choose my copy data activity, and within source now I should see the existing data set which we just created, ds blob underscore text, and we can just choose this data set, and once again if required we can also create a new data set right from here. So if we click here, it will create new data set, and while creating data set we can also create a linked service. So I hope by now it should be very clear how we define the dataset and linked service. Let me go back to my slides and just quickly revise all the points we just discussed. All right, so we discussed that dataset is simply a point or reference to the data at the data store. So this is important here to understand that dataset does not have the data in itself. It is just a reference. So if the data change at the source, it will also reflect those changes at dataset. And we can have reference to the files or folders or documents or in fact tables also. So let's go to the next slide, which is linked service. And linked service is similar like a connection string which we have in SSIS, and it has both the connection information as well as credential information. And linked service, we already saw there are two types of linked service. We can have connectors to connect with the data store like Azure SQL Database or the Blob we just saw, or we also have compute resources like Spark cluster or Data Lake Analytics or Databricks. We saw all those examples. So this looks good. Let's go to the next slide. And here this is the diagram from Microsoft. It now should be very easy for you to understand. Pipeline is a logical grouping of activities. We are fine with that. And activity consume data set. So we saw that copy data activity. In copy data activity we required source. When we were defining source, it required data set. So it consume data set, and if it does some processing, after processing it produce again data set, and this data set represent the data item stored at this location, linked service location. And of course linked service location has address as well as the credentials. So activity runs at this address. It refers the data to the data set, but it actually runs at the linked service. So I hope by now these components are clear, and in the next lesson we are going to discuss about the integration runtime. Thank you. Above this line we have cloud. So if source or destination, any of those in the on-premises or in the private virtual network, we will install SSIS either in on-premises or private virtual network. Or if both the source and the destination are in the cloud, we can just use SSIS within the cloud, SSIS integration runtime. And if the source or destination is in the cloud but in private virtual network cloud, we need to install self-hosted in private virtual network cloud. If any of these in on-premises, below the line, we need to install self-hosted in on-premises. And finally, we have the Azure integration runtime, which always deal with the cloud. So source and destination both are in the cloud. So we can just directly create and use Azure integration runtime from here. So let me go to the portal and show you how this works. So we have Azure and self-hosted. So if I select this and continue, I have option to choose Azure, which also can be this similar to this default one, and I can continue here. I can provide my name, and I can provide the region, in which region I want to install this. So auto resolve means Azure will figure out by itself, but you may have some specific requirement. So for example, let's say your source and destination both are in the UK, and you don't want your data to leave the network of UK. In those scenarios, for example, you may want to install your one second, let me find out where is UK. Here it is. So in those cases, you may want to install your integration runtime within the region of UK so that your data never leaves the UK. Or as I said, you always have option to auto resolve if you want. So anyway, you can provide your name, the name of integration runtime here, and you can just click here and it will create new integration runtime. You see it has already created. Or other option is, you can continue here and you can go to the self-hosted and continue, and you can give some name here, maybe IR self-hosted, and you can give some description and type and everything. And then when you continue, now here Azure is giving you option to download integration runtime setup, install it on your on-premises network wherever you want to run it. Maybe it is in virtual private network, maybe in on-premises. So install it there. When you install it, open it, it will ask for the key, and you can copy this key from here, paste it there and click on register, and finally your integration runtime will be set up on your on-premises. Alright, so actually I just paused my recording here to find out the screenshot of how it looks when you install it. So this is how after you install it on your laptop or an on-premises environment, when you open it, it will ask for the registration and it will ask for the key. And at that time, you can provide this key. You can copy and paste it there, and then you can register it. And once you register it, you are ready to use it. And then once you install it, if you go to the notes means basically your laptop or your on-premises system where you installed it. So you can see all the notes here where you have installed this integration runtime. So basically the point is you can install the same integration runtime in more than one system, and I think maximum 4 you can do that. So for example, if you install in 2 or 3 system, you can see all those notes here. And then you can also click here to auto update it. So whenever there is any upgrade in the integration runtime setup, it will by default upgrade it for you. You don't have to do it manually, and if you want, you can turn it off, the auto update. And then you have the sharing. Sharing means you don't have to install self-deployed integration runtime for every data factory instance. If you have more than one data factory instance, for example, if I see here, if I go to my resources, I have one other resources, and here I have one more data factory. I have this data factory 108. So for example, if I open this, I don't have to install the self-hosted environment in this data factory also. If I want, I can avoid it. I can just use this resource ID, and I can go here. I can launch my author and monitor for this data factory instance, and once it comes out, I will go to my manage integration runtime, new self-hosted, and now I will choose this linked self-hosted. And when I choose this, it will ask for the resource ID, and this resource ID, I can copy it from here and I can paste it here, and I can continue, and I can create my self-hosted integration runtime right here. So the same integration runtime can be shared among multiple data factory instance. So in future, I will try to add a demo explaining this integration runtime self-hosted environment. But as of now, I think the point is clear. What is integration runtime? This provides the compute infrastructure to your activities, to your pipeline, and this is the one who actually perform the task. And if I go to my slides here, so as we already discussed, the default IR is auto resolve integration runtime, and this is auto resolved by data factory itself. And create Azure integration runtime. So why we create Azure integration runtime? Why we always cannot use the default one, auto resolve one? So as we discussed, that if we have the requirement where we want to explicitly define the location of IR, like we discussed the example of UK, In those cases, we may want to create a separate integration runtime. Or maybe there's some management purpose, there's some requirement where you want to group some of your activities and execute for some particular integration runtime, maybe for the security reason, or maybe for whatever reason. If there is some such kind of requirement, then also you can create separate Azure integration runtime. So I hope this has cleared the concept of integration runtime. In next lesson, we will be discussing the triggers. Thank you. Hello friends, in this lesson we will continue our discussion on Data Factory important components, and in this lesson we are going to discuss about the trigger. Now trigger is to run the pipeline or initiate the pipeline or trigger the pipeline basically. So for example, in the pipeline, in this canvas page, you can see we have option here, add trigger, and if I click here we have option to trigger now, and this will run your pipeline immediately now. And then you have option to create more triggers. So if I click on new, you can choose the existing trigger if you already have. If not, you can create new trigger here. And if I click on new, the new window will open. And here we can see we have option to create a trigger. So you can give the name of trigger and whatever description you want to give. And then you can see we have three options here. So basically there are three types of trigger: schedule, tumbling window, and event. So what is schedule? When you want to schedule to run your pipeline at a particular day or time, you choose this trigger. So you can choose the date here when you want to run this pipeline. Let's say I want to run this pipeline from Monday, from 13th. And then what time, and you notice that the time is in UTC, universal time. So what time you want to run this pipeline. So let's say I can say that I want to run this pipeline at 10 a.m. in the morning. And how many times you want to periodically run this timeline: every minute, every hour. And when you choose every day here, you see we have option to change the time if you want. So not just change the time, in fact you can even add more timings you want. So for example, you may want to run this pipeline 3 times a day. So you can say I want to run at, let's say 11 a.m. Oh sorry, this is in UTC. So 11 a.m. Or you can say I want to run in the evening at 4 p.m. So that means 16, or maybe in the night once again at 8 p.m. So that is 20. And here you can also mention the minute. So for example, let's say if I say 30, then it will run at 11:30. You see the time here: 11:30, 6:30, and 20:30. So basically you can design your hours and minutes here in such a way that you can run this pipeline multiple times a day. Similarly, you can choose the week here, and then you can choose whatever weekdays you want to choose. For example, I want to run every Monday and Thursday on this time. Similarly, you can choose the month here, and for example I can say every 9th, 17th, and 25th of every month, and at this timing at 11:30, 6:30, and 20:30 UTC time. So basically you can design and you can schedule your pipeline according to your needs. And then we can have either no end of this schedule, and it will keep running until you manually stop it, or you can choose the end date here. And then you have annotation. Annotation is just like a tag. You can add another tag to any of the resource of Data Factory, whether it's a pipeline or it's a trigger, and then later you can search all the resources which are tagged to a particular annotation. And here you can activate it if required immediately, or you can just design this trigger right here and do not activate it, and you can come later and activate it whenever required. So this is schedule trigger. And then we have tumbling window trigger, which is kind of advanced version of schedule trigger. So you can see here once again we have the start date, and then we have the recurrence every minute and hour. We do not have days and weeks and month here, and there is a reason for that. Tumbling window, once you understand why tumbling window is designed, then you will understand why we do not have these windows here. So first of all, tumbling window can also be run on the back days to do the backfill. So for example, for some reason, XYZ reason, let's say our pipeline for yesterday or last week did not complete. And now we want to schedule it for, let's say 6th, the last Monday of the week. And I say, okay. Now, if our data have a timestamped value, this window, this trigger will run for the last week. It will match the data in our database, for this timestamp. So basically we can use this tumbling window for backfilling purposes. And then we have, of course, we have the end date here if required, or we can put the no end date. Now, if you see, we have advanced options here, and this make all the difference. So for example, let's go one by one to all the settings under the advanced. So you can see we can add the dependency here. That means we can depend one trigger into another trigger. So for example, trigger B may depend on trigger A. So what does that mean? So sometimes we have seen in the real-time scenarios that in our upstreams or downstreams may have the dependency on each other. So for example, I may have a pipeline to run every hour a day, and in the night I run another pipeline which will process the data of already processed by all the day pipeline. So all the data processed in a day, I want to do the final processing in the night. Now, when I run the night pipeline, I want to make sure that all the pipelines in the day should complete successfully. So by now, there is no way to check that unless we have to custom, write the if-else command and manually check whether all the previous pipelines completed successfully. But now in this tumbling window, we have this option here. We can define the dependency. So we can define the trigger here. If trigger A completed successfully, then only this trigger will be started. And after this trigger, you see we have option to choose the offset and window size. Now, let's see what is this. So offset means so let me go into the page here, and Microsoft has designed these examples to explain the offset and window size. So let's look at this example. So in this, trigger A depend on trigger B, and we have offset of -1 hour. That means the window of trigger A, which is going to run from 10 to 11, is depend on trigger B window from 9 to 10, because there's an offset of -1 hour. That means if trigger B window 9 to 10 complete successfully, then only trigger A window 10 to 11 will continue. Similarly, you can see we have another example where the size of window is 2. So we have another option here, window size. So that is 2 here. That means not only it will check the previous window, but the size of those two window, that size of that window should be 2. That means it will start looking from the previous window, and it will look for 2 windows because the size is 2. So when we define the tumbling windows, basically we choose the hour or minute here, and it creates the different windows to run that pipeline. So for example, let's say if I say every 1 hour here, so if I say every hour, that means within 1 day, 24 windows we have for this tumbling window trigger. That means 24 times this pipeline will trigger. So, and if you go back here, so let's say we have window of every 1 hour here, then trigger A window, one window will depend on trigger B, another window, the previous window, if the offset is -1 here. And then we can also have the self-dependency. That means if the previous run of the same trigger completes successfully, then only this particular trigger will run. So 10 to 11 will run only when 9 to 10 of the same trigger completes successfully. And if it is not, then it will wait and then it will run. And this is basically another beautiful feature of Tumbling window, that it says it is more reliable because it does not lose its time. So for example, let's say this window was supposed to start at 10, but because this got delayed for some reason, let's say 15 minutes or whatever, and then this trigger, instead of 10, it started 10:15, but the time will remain at 10. The window time will remain at 10. So for example, if your database have a timestamp value and you are processing that using this time window, so that will not change. Your data will process from 10. In fact, in spite of the fact that triggering window will start at 10:15. That's why the tumbling window is more reliable than schedule window also. And then we have some more options here. For example, we have delay. That means if we want to delay our pipeline for a few minutes or few hours, so we define here at 10 a.m., but we can have delay of 15 minutes. So instead of 10, it will start at 10:15. And then we have max concurrency. That means how many windows we want to run parallelly. So for example, we have a scenario where we want to backfill our data of yesterday. And then we have 24 windows of yesterday because we are running our pipeline in every 1 hour. So we have total 24 windows of yesterday. And we can choose here value 10. That means 10 windows will start parallelly at the same time and will process the data at the same time. So for example, let's say yesterday we have windows from 1 to 2, 2 to 3, 3 to 4, 4 to 5. Similarly, the first 10 window, that means from 1 to 10 to 11 p.m. in the night, basically first 10 windows will run at the same time, will process the data. And once those 10 windows will complete, another 10 windows will start. So from 11 to 12 and 12 to 1 and so on. And once those 10 windows will also complete, then so far we have completed 20 windows, then the remaining 4 windows will start. So basically how many windows you want to run at the same time. And then we have a retry policy count, how many times we want to retry in case of failure, and what should be the interval in between those retries. So if we have 30 seconds, that means if our pipeline fails, it will wait for 30 seconds and then will start again that pipeline. And then we have option to whether we want to activate this now or we want to select as a no as of now, and we will come back later and activate this trigger. So you can see that using the tumbling window, you can really define a very complex dependencies, and practically you can handle any real-time situation or scenario to process your data, whether the past or the future or of course the present data processing. And next we have the event trigger. Now this will be easy. Event trigger simply covers the scenario that if your any storage account or the container has any new file or any file deleted from that container, then event grid will raise an event, and using that event we can process that file. So once again you can give the name and description, and we have chosen the event here. And now I want to choose my account, so I can choose from my Azure subscription, or of course you have option to enter manually. So I will choose subscription here, and then one of my account name, so let's say Azure storage, and I will choose one of my container, ADF input 01. Now if in this container, if I upload any new file or if I delete any new file, this trigger may get triggered. I mean, this trigger may get start. And I have option here, and I have option to choose here. You want to choose if blob created, means if any blob uploaded or any blob deleted or both, I can start this trigger. And I can also define the blob. For example, my blob start with the particular date or maybe name of project or something, or maybe my blob end with, let's say, JSON, .json or .text or any other extension, and it will process only those kind of blobs. And we also have option to choose here, if my blob is empty, then you can ignore it. So basically it's this trigger is handled by the event grid, which is another service of Azure, which which work across different services, and which raise an event in case of which trigger an event in case of any of these blob related file uploaded or deleted. So we have three triggers as we discussed. We have schedule, we have tumbling window, we have event trigger, and we can define any of these trigger to any of these pipeline, and we can define one trigger once and we can use the same trigger for multiple pipelines. So for example, you see we have option here to define the trigger, and also if you go to the manage here, you have option to define the trigger. So you can design the trigger and it is independent of the pipeline. And once we have this trigger, so for example, let's create this trigger 1, and just click on OK. It has created some trigger here. And now if I go back to my pipeline here, and if I say new trigger, and I can select the existing trigger, and this is the trigger. I said okay, I'm fine with that. Okay, so I have to publish this trigger before I can use in this pipeline. But again, the point I'm trying to say is you can define the triggers here and you can use the same trigger into multiple pipelines, or one pipeline can have multiple triggers. So one pipeline can have 4, 5, or we can add multiple triggers into the pipeline. All right, so I'm back to my slides, and let's quickly look at all the points which we just discussed. So triggers execute the pipeline. All right, so I'm back to my slides here, and let's quickly look at all we just discussed about the trigger. So trigger is used to execute the pipeline, and we can have many-to-many relationship between pipeline and trigger. We just discussed that one trigger can be used to execute multiple pipelines, and every pipeline can have multiple triggers. So there's many-to-many relationship, except the tumbling window. Tumbling window is especially designed for one particular pipeline. And we have three types of triggers. One is schedule trigger, in which we invoke the pipeline on a wall clock schedule, and we just discussed that we can define the schedule for per day or per week or month, and we can have different timings in a day and month. So we discuss all those possible scenarios in schedule trigger. And then we have tumbling window trigger, which operates on a periodic interval. So we can create for every 15 minutes or every 1 hour or whatever required. And this also retain a state. This is very important. That means even if trigger start late, it maintains its state of that periodic interval. So if the trigger is supposed to start at 10, but because of some reason it is start at 10:15, but the time of the windows, you see here we have window start time, which we can access here, triggers dot output dot window start time. So this start time will remain 10, even if it is starting at 10:15. So that's why it is considered as more reliable, and it retains its state. And as we just discussed, it is one-to-one relationship. So tumbling window we create specifically for a particular pipeline. And then we see that, and then we saw that we have advanced configuration options here. We can have the dependencies of the trigger into other triggers. We have option to define the delay or retry. And we also saw that we can define the concurrency, how many triggers can run parallelly. And as we just discussed that we also have option to access the properties triggers dot output dot window start time and end time, and we can use this in our code as the wherever required. And last, we have event based trigger, and this trigger pipeline in a response to an event. And there are two types of event which right now handled by this trigger, which is arrival or upload or addition or creation of blob, or deletion of blob storage, file in the blob storage. So if any of these two events happen, then it will trigger or it will execute that pipeline using this trigger. And then event trigger with the Azure Event Grid Service. As I said, the Data Factory work with the Azure Event Grid Service to handle these kind of trigger. This is a separate service, and this service can work with all other services to handle different events. And then when this trigger initiate, we do not have any other information except the folder path and the file name which is added or deleted. And using these properties, we can access exactly which file is created or deleted, and then we can work around with that file. So that's all with the trigger right now. I hope you have a good understanding of trigger by the end of this lesson. Thank you. Hello friends, welcome back. And in this demo, we are going to use one of the most commonly used activity for Data Factory, and that is copy data activity. And right now I am inside my Data Factory, which we created earlier. So I hope you are following this course in sequence. And so far we have discussed all the important components of Data Factory, like integration runtime, pipeline, activity, triggers, and so on. So now in this demo, we will use all of those components which we discussed in the previous lessons, and we will create copy data activity. So right now I'm into front page, in the home page, that is Data Factory, and we are going to use this copy data wizard. So let me go back to my slides and show you what all we are going to do in this demo. Alright, so I'm into my slides right now, and you see we are going to use Azure Data Factory copy data pipeline to copy data from Blob storage to Azure SQL Database. So once again, we already have created Data Factory earlier in one of the lesson. In this lesson, I'm going to very quickly create Blob storage and SQL Database. If you already have these resources, you can skip first few minutes, or maybe you can fast forward, whatever you like, or you can just follow me and quickly create Blob storage, SQL Database, and then we will upload the files on the Blob storage, our input files, and those files we will further copy into our Azure database. Alright, so I'm back to my Azure portal, and let me go ahead and create Blob storage first. So let me go to the home here, and let me search for storage accounts and create a new storage account here. And we can name here, and we can select here the subscription and resource group, and we can give name to our Azure storage, maybe Azure Blob storage 108, just to make it a unique. And then we have a location, West US 2, standard performance, version 2, replication, I can choose the cheapest one, and the access tier hot is fine, and I will just click on review and create directly without going to all of the settings. I'm fine with the default settings right now, and let's just create the storage account. Now it may take a few minutes, and meanwhile this create, we can also quickly create our SQL database. So let's search for SQL database here, and we will add a SQL database instance. We will select the subscription, resource group, and then we'll give some name to SQL database, maybe SQL DB. All right, interesting, I'm able to find it, but still I will give 108 just to keep it consistent with other naming convention. It seems like our deployment complete for Azure storage, so that is quick, so this is good. Now let's quickly create a server here. Come on. All right, so DBS 108. Okay, we don't have this, just add another 8 to make it a unique. All right, so here we need to give some credentials to log in back into this database server. All right, so let's choose the same location where we have our storage, because it is good to have all our resources in the same location, so that we can save some money in data transmission, and also it reduces the latency. So this looks good. SQL static pool, we don't need it right now, and I can configure it once again to the lowest one, because I don't need a whole lot of hardware to show this demo. So I'm fine. It's just going to cost me $5 per month, which is okay. So apply, and I don't need to go to all of the settings. I will just directly click on review and create, and we'll just click on create, and it will deploy the new SQL Server for me, Azure SQL Server. So we saw that we have our storage account ready. So let's go to the storage account. So this is the brand new storage account, and I will go into the container, and I will create a new container here, and let's call it import Azure Data Factory, or maybe Azure Data Factory import. All right, underscore is not allowed, so let's try this. Okay, so this worked. And so this is our input folder for Azure Data Factory, and here I want to upload few files. So I will select the files, and I have two files here. One is product and product category, and I will provide these files in the demo resource lesson folder. You can find it. So let me upload these files here, and both these files we have product, and in product, let me show you this file once again. So if you look at this file, we have the data related to product ID, name, product number, and all that, and we have one column here, product category ID, and you can see that this is a comma separated file, and it has around 296 rows here. So we have product category ID column, and we have another file here which have product category ID and what is the name of the product category. But anyway, in this demo I'm going to use only product table, but in the upcoming lessons we will be using both of these files. So just wanted to show you what files I'm talking about, and you can see that our SQL database is also ready. So let me go inside this, and this looks good. So we have our source ready. Now let's make our destination also ready. So let me go to the query editor here, and I will not be able to log in most likely because I have to add my IP address here. Yes, I'm getting errors. So let me quickly go to the database server. So I will select the server name here from the overview page, and inside that I'm going into the firewall settings, and I will add my IP here, add client IP. You can see this will add the IP of my laptop where I'm recording into the SQL Server, so that I can access it from a laptop. And here it seems like it is a little bit more restricted than required. So right now Azure services cannot access this server. So let me allow access from the Azure services. It is okay to not have access from the public, but I think this was required. So let's save these settings here, and once this is saved, now we can go back to our server, so we can see our SQL database is right here, and this is our SQL database. And once again I will go to the query editor, and I will type my password here. All right, so now I'm inside the SQL database. So let me go back to my folder, resource folder here, and I will create a product table here. So this is the code to create a product table, and again I will provide all this into the resources section. So let me create this table here, and I want to create one more table. Let's do it right away, even though we don't need it in this lesson, but we are definitely going to use this in the future lessons. So let's create the product category table also. So if you go inside the table, we have both these tables, product and product category. So we are good. So let's go back to the slide. All right, so we have our source ready, and we have files inside the blob storage, product and product category, and we are going to use a product table or file in this demo. And we have our destination ready, and we have tables there. So we are going to read data from product file, and we are going to copy it into the destination, which is Azure SQL Database, using copy data activity. You might have noticed that I was very quick when I was creating blob storage and SQL Database, and there was a reason for that, that this lesson is not focused on how to create blob storage and SQL Database. Otherwise it will take a lot of time to explain these resources. My focus should be on how to copy data, the copy data activity. So I'll take time there and we'll explain all the properties of copy data activity. So let me go back to my portal once again. All right, so I'm back to my portal. And once again, I'm into Data Factory kind of home page. And in this, I'm going to use the copy data wizard to copy data from source, which is Blob storage, to the destination, which is SQL database, Azure SQL database. Now we have, you see, we have 6 steps here, and this is very easy. All we have to do, just keep following the wizard. Just fill the required information, click on next, and at the end, we will be able to deploy the data factory. So as we already discussed, we have a source here, which is, and then within the source, we have linked service, we have data set, then we have linked service for destination and data set for destination, and then few more settings. And then we will just look at the summary to make sure everything exactly what we want. And then finally, we will deploy the data factory. So it's very easy. So let's move forward. So in this task name, we are going to provide the name of our pipeline, and should be copy data from wizard maybe. And then you can give whatever task description you want to give here. And then you want to run this pipeline only once or multiple times regularly. And if you're following this course, we discussed about the trigger. So if you click here, it will create the schedule. I mean, you can create the schedule or tumbling window triggers right here. And I'm not going to explain this because I've already took a lot of time to explain this in previous lessons. So if you need, you can refer those lessons. So in this demo, in this lesson, we want to run it only once. So I will select this and go to the next. And here we want to create our linked service to the destination, to the source. So again, we have already discussed about link service in detail. We have different categories here. So right now I'm trying to create a link service to my source, which is Azure Blob storage. So I will click on Azure and I can say the create new connection. And within Azure, I'm looking for Blob service. And of course, you can always search it here if you cannot see it right here. And once you have Blob storage, you can select this. And then you can provide the name of your link service. Maybe I can say Azure Blob storage 108, or maybe just Azure Blob storage. This is fine. Okay, so now here we can have underscore. So let's do that. Now here you can provide the description, whatever you like. And here is the default integration runtime. And we discussed all the different types of integration runtime previously. In previous lessons, so you can refer that. But in this lesson, we are going to use auto resolve integration runtime because we are going to copy data from within the cloud from source and destination. Both are in the cloud, so this should work fine. Azure Data Factory will figure out what should be the best settings for integration runtime. And they will provide it. So I don't need to change anything. And then we have different authentication methods, and we have service principal, manage identity. So you can use as per your need. But in this lesson, I'm fine with the account key. And then we can have the connection string stored within the key vault. So if you're using key vault, you can have your connections and credentials and everything saved there. But right now, let's move forward with the default value, which is connection string here. And I want to take the connection string from my Azure subscription, and I will choose my subscription here, and it will show all the storage account I have within this subscription, all the Blob storage account. So I have so many. I think we created this one, if I'm right. Let's just quickly double check. I'm a little confused here, so just want to make sure I choose the right one. So within course demo, we just created Azure Blob storage, and within container, I have this ADF input, and I have these 2 files. So this is my Blob storage, Azure Blob storage 108. So I want to make sure I select the right Blob storage here. And then you have the test connection. So we want to test the connection to the linked service. So let me test the connection, and it should be fine. We have successful connection, and we can create our linked service connection. So now this linked service contains the connection as well as credential for the source. So we are done with the connection part. So let's move to the dataset part. So let's click on next here. And now here we need to select our source input data, so that Data Factory can figure out the structure of the data as well as the exact location of the file. So we will choose the file here. So let's click on browse, and within ADF input we are working with the product file right now. So let's click on choose here, and then we have few more settings here. Our input file is not a binary file, it is kind of text file or CSV file, so it is okay to uncheck this, leave it unchecked. And then recursively, if we have the folder here, and within folder we may have the multiple files, or maybe the folder inside the folder, and in that folder we may have a multiple files. So if we have this check here, it will run all the file one by one within that folder, or in fact the folder within the folder. So I can uncheck this because we don't need it, or even if you leave it, it's okay because we don't have many files within that folder. And then we have the max concurrent connection. That means how many connections at the same time we can have with the source. So Azure Data Factory itself will figure out this value, the best value. But if you want, you can manually provide the value here. And then let's say if you have many files and you want to run file, let's say for yesterday, then you can provide the value here, start time and end time of file last modified date. So in that way, you can basically limit the number of files or the files for particular day or time to process by the data factory. So we don't need all of these settings right now. So I can go to the next, and here we have the file format setting. So Azure Data Factory is generally very good to figure out the format, the schema of your file, and it will also show you that this is what Azure Factory thinks that is the schema of your file. And you can go to schema, and you can see right now the property 1, 2, and 3. But if you look at the file here, we have actually the column names here. So let's look at the file, and we have product ID name, but it is not able to detect it here because we have not yet clicked the first row as a header. So let's check this box, and now Data Factory still not able to find out the column name. So let's see what's going on here. So we have text format, file format, which is good. Our file is comma delimited, so that is also good. Row delimiter, which is good. We have /n, so it should work here. Skip line 1. Okay, so this is the problem. Why we want to skip? We do not want to skip any row. So let's click on 0 here, and now you can see that we have product ID name and product number. This is our first column, and this is our data, which looks good. And within schema also we should have the right columns name here. You can see that. So this is good. We don't need to change anything else, and let's go to the next here. Now we have come into the destination section here. Source section have been completed. We have defined the link service, data set, and file format and everything. Now same thing we have to do for the destination. So let's once again go to the Azure and try to create a connection here for Azure SQL Database. So let's search for SQL Database here, and we have Azure SQL Database. Let's select this and give the name of linked service, maybe SQL Database here, link service. You can provide the description. Integration runtime is auto, which is fine. Connection string, we don't want to use the keyword, so this is good. We want to choose our Azure subscription, so let's choose our Azure subscription here. And now what is the server name we have? I think this was the server name we were working in. And once again, if you want to just double check to make sure we are on the right, so this is our DBS 1088. This is what we created just a few minutes back. So we are good here. Now which database? We created SQL DB 108. So this is good. Now authentication type, SQL authentication. This is good. And we can provide the credentials which we created while creating this database server. All right, so this is good. This should be good. We do not have parameter as of now, and it's okay to leave the advanced settings as of now. So this looks good. Let's test the connection. This is good. So let's create this linked service connection. So right now we have a linked service connection to our destination. So let's go to next here, and we have to choose the destination table here. So if you remember, we are shifting or moving or copying the data for the product table. So I will choose that, and let's see what are the settings we have. Now here Data Factory once again figure out the schema of the destination table. So we have product ID and all those columns. So this is good. So let's go to the next here. And now here we need to do the mapping from the source to the destination. So you see that once again Data Factory has done all the all this mapping for us. We just need to double check to make sure everything looks good, and if there is some error it can show it here. So there's a warning that the cell end date data may not be get into the cell end date, because we have the date time here, and Data Factory have figured out this is a string. So if you want, you can change it to date time, and even if not, then also it should be fine, because we know that we have data here of type date time, so it should fit into this column, so it should be fine. So if you want, you can change this also, or otherwise you can leave it. It won't make a difference. So this looks good. Now we have few more settings here. We have pre-copy script. That means if you want to write a script to delete the data from the destination before running this copy data, because for example, let's say if you want to make this pipeline to rerunnable, you want to run this again and again. So every time you run, you want to make sure that you do not duplicate the same data. You want to delete the data from the destination. So you can write those kind of scripts here. And then we have write batch timeout. So let's say if for some reason your destination is busy and this pipeline is keep trying to write data but it's not, then how long the pipeline should wait? Few minutes, few hours, few days. So you can mention the timeout here. I think by default is 7 days or something. Similarly, you can write here the batch size. So for example, when Data Factory write the data into the destination, it creates a different batch. Just to give an example, let's say maybe of 100 rows batch or 1000 rows batch. So what should be the batch size which you want Data Factory to write data to the destination? You can select it here. And then we have once again the max concurrent connection. That means how many connections you want to have with the destination. And once again, Data Factory can figure out this value dynamically by itself. So you do not have to provide it unless you know what you're doing and there's reason behind that. And here we have disable performance metrics analyze. So when Data Factory run the pipeline, it collects a lot of data, like how many rows copied, how long it took to copy those rows, how much resources Data Factory used to copy these resources. So if you want, you can disable that, or if you want, you can leave it, and you can later analyze and see that how many resources Data Factory utilized for this particular copy data activity and how much it actually cost you. So we are going to leave all of this as of now. We are not going to use it, but I just wanted to explain all of these settings. So let's go to the next here. All right, so if you see, we have completed the destination portion also. So we are done with the source, destination, and next is the setting, and this is the last one. Once we complete this setting part, all we have to do is just review and deploy our Data Factory. So now in the setting, first property we have is the fault tolerance. That means if there's some issues with the rows, what do you want with that row? So you want to skip that row, so you can select it here. And if you want, you can also log these rows which had some values here. So if you select that, you have to again choose the connection where actually you want to store these rows, and then you can choose some storage, and then further which folder you want to store these rows, and you can come back later and figure out what you want with these rows which is having some kind of error. So right now we don't need logging. In fact, we are fine with not selecting this, or you can just, no, we want to see error. If there's some problem with the copy data activity, we want to see error, so we don't want to select this. I will let my Data Factory pipeline fail in case of there's some error, but in production like scenarios you can use this setting. So fault tolerance, and then we have the enable staging. Do you want to enable the staging? So when Data Factory copy data from the source to the destination, there's an option of the staging where data will not directly be copied from source to destination, but the data will first copy from source to the stage, and then from stage data will be copied to the destination. Now why we do that? Because in general Data Factory copy and to the destination in the row by row, few in the form of few batches. But let's say you don't want that. You want to have the bulk copy write. So in that case, you can enable the staging, and we generally do this in production. In that case, we will not write row by row or in the small batches. We will first collect the data in the stage, and once we have that data, we will bulk write that data into the destination. So once again, if you have this setting enabled here, you have to select the your staging area. In that case, again, you will select some of your storage where data factory, which data factory can use as a staging. So we don't want that, so you can disable this. And then we have the next setting, which is data integration unit, and this is under the section of advanced setting. So what is data integration unit? So as we know that in cloud, we do not have direct access to the CPU or memory or other network resources. That is everything taken care by the Azure. But Azure provided us some unit which represent this hardware. So for example, in SQL Server, we have DTU, or vCore, or in Data Factory, we have DWU. In Cosmos DB, we have RUs. Similarly, in Data Factory, we have DIU, Data Integration Unit. So this represent how much hardware we want, how much CPU power we want, how much memory we want, how much network resources we want. So it defines those hardware. So if you want, we can assign a particular DIU value here, or you can let Data Factory decide that. And Data Factory dynamically will assign whatever required DIUs to your pipeline. So I will leave it as an auto here. And then the next and the last setting we have is degree of copy parallelism. That means how many parallel thread you want Data Factory to run to succeed this copy activity. So you can have 5 threads or 10 threads, depends how many threads you want. But again, Data Factory dynamically assign this value to this property. So unless you have any particular requirement, unless you know what you're doing, you can leave it as a default, and Data Factory will take care of this. So this is all we have in the setting page, and we can go to the next here, and we are done. We have completed all settings for source and the destination, and all settings in the setting area. And here we have to just review what all we have selected. And so let's look at quickly. So we have our connection to the Blob, and this is our file which we want to copy, product.csv. And then in the destination, this is the table in SQL database, which we are trying to in this table we are trying to copy data. And as I told you, this is the default value as a 7 days. So for the next 7 days, it will keep trying to copy this data unless there's some issue and before it throw out the error. And we do not want to retry. Retry interval is 30. There's no retry, so this value doesn't make any sense, but still this is the default value. And we have not chosen to have a secure input and output. So I will explain that in the next lesson, these values. But anyway, as of now, this looks good, and we can go to next. And as soon as I click on next, it will immediately validate if everything looks good. If you remember in the previous lessons, we discussed that what validate means. It validate if we have provided all the minimum required values, and then it creates the data sets and the pipeline, and now it is running the pipeline. And if you want, we can go to the monitor to see what's going on with this pipeline. So let's go to the monitor and see it has failed. Interesting. So let's see what's going on here. It's good that it failed so that we can see how to figure out the error. First of all, before we look into this, very quickly, when we clicked on monitor, we have come into this monitor section. And in this monitor section, we have different categories. Like we can look at all the triggers, we can look at the pipeline and integration runtime related activities going on. So right now we are in the pipeline run, and this is the pipeline. If you remember, we created copy data underscore wizard. And here is the error. So let's look at the error. It says, so there's not much information here. So let's go inside the pipeline. And when I go inside the pipeline, I can see all the activities here. So right now I only have one activity, which is failed. You can see the red cross here. And if we have multiple activities, we can see all of them here. And here we also have option to rerun that failed activity. So if we think that this may be because of just network issue or something, we can, or if you have already fixed that activity, you can run this. So we are going to use this. So let's leave it for now. And here is the activity we have, copy data activity. And here you can see we have the error for this activity. So let's click here and see what's going on. So it says that the error found when processing this file, and with row number 2 found more column than expected. All right, so there's an issue with the input file. So let's go back to the file which we are working with, our input file, and we created this blob storage. We'll go inside the container and the folder, and this is the file which we are working with. So if we go to the edit here, and we can see the file, and it looks like we have one extra column here, and so this is blank for in every row, and we have one extra column. So let me go back to my folder where we have this file. All right, so I'm into my resource folder, and let me open this file. We have this product file. So let's open this file and see what's going on here. And you see we have this extra column, it looks like. So we have this column, which is extra column, and that is what causing an issue. So I exported this file from SQL Server. So I don't know, for some reason the extra column was exported. But anyway, let's quickly delete this folder. And this looks good. This is a small file. We do not have many rows here. We just have 296 rows. So this looks good here. Everything else looks good. So let me save this file once again. And I will and then let me close this file and go back to my storage, and let me upload this file once again. I will choose here the product file here, and I will write it overwrite if my file already exists, and click on upload. This is a small file, though this should be good here. Now let me go back to my data factory and rerun from failed activity. So let's say if we have multiple activities here, and let's say after 10 activities, this activity fail. So we do not want to run all that activity once again, right? It may take a couple of hours to reach to that particular activity. So we have option here to run that failed activity. So let's click here and rerun. Are you sure you want to rerun the pipeline? Yes, I'm sure. So let's click on OK, and it may take few minutes or maybe few seconds before it complete this pipeline. All right, so this pipeline completed successfully. Let me go to the destination and see that if we have the rows. So let me open another tab here, and in this tab, let me try to access my destination, that is Azure SQL Server, which we created earlier in this demo. So this is my SQL Server, and I will go inside the databases here, and I have the SQL DB 108, and I will open the query editor from here to access my tables, and let me provide my password here. All right, so this should be good, and we have table product here. All right, so I'll do my select top 1000 from here, and I should see rows here, right here. Okay, so this looks good. We have total how many rows we have? There should be around 237 rows. So let's collapse this to get a little bit more space here. And if I go down, let me do the select count from here. dbo.product. All right, so if I run this query here, oh, I'm sorry. All right, so we have 295 rows here as we had in the source file. So we are good. Let me go back to my slides quickly to conclude what we did in this demo. All right, so in this demo, first we created the blob storage, and then we created the SQL database. In the blob storage, we uploaded files, input files. In SQL database, we created the destination tables, and then we created copy data activity, and we used the wizard to create that activity, and we used that activity to move data of product file to the SQL Server destination. Now in this demo, I was very quick while creating blob storage and SQL Server because my focus was on the copy data activity. And in copy data activity, I tried to explain all possible properties, and that took a little bit a while, and that's why this demo is a little longer than usual. But I think that should be worth if we understand all the properties of copy data activity wizard. Thank you.